trying to do is get this product to the customer in new condition. Not only does it need to arrive in new condition, however, HV packaging needs to be recyclable and in some cases reusable. We also have to use locally available products. If I'm in North America, there are certain products available to me. There's certain types of fiber, there's certain types of corrugated material and foam. If I go to Australia, for example, there's exactly one type of packaging foam available to me. So I have to make a design that uses that packaging foam. If I go to the Far East and buy corrugated material, it's made primarily out of rice stalk materials. If I'm down here in the Southeast United States, I'm using a certain percentage of post-consumer recycled fiber, but I'm also using a decent percentage of the world's finest paper, which is our pine trees that we grow in this area. We have nice long fibers, makes it very durable and tough. So what we're going to do here for you now is we're going to drop this pack. This is going to simulate a 30-inch drop. The table will not rise 30 inches. Normally this pack test would take place with a combination of free fall drops and table drops. The purpose of the table, if you look behind this gentleman, is that I get very clear axes of data that come from the sensor that is glued to the desktop inside. So I have a triaxial accelerometer that will give me the G-level responses of the actual product inside the pack. So John, if you want to go ahead and give us a drop, this is very loud. I warn you again, very loud. And here it goes. Okay, that would be one drop out of 19 for this particular pack. What you'll see over here on the screen will be the results of the drop. So what we've done is at 30 inches at the required velocity change, because you've heard the joke, it's not the fall, it's the sudden stop. So the packaging drop is controlled by the velocity change. What we've got here is a set velocity change. It ends up being about 380 times the force of gravity. And that's been turned into 53 times the force of gravity in the product, down from 380. So the package absorbs the energy, and if you'll look at the curves here, if anybody remembers their mathematics, you've got a half sine curve, and it trails off, so that's your drop. That's the table, that big one, that's the spike. The packaging, the foam material absorbs the energy of the shock and then releases it more slowly. So then we've got that nice, slow, long, little half sine in the middle instead of that very sharp, short one. The sharp, short one is what breaks things, and the